Assalamualaikum. Nama saya Ahmad Aidil bin Azhar. Nombor kad matrik 13 DEP 22F102 1012. Nama ahli kumpulan saya Muhammad Nasrullah bin Azwar dan kad matriknya 13 DEP 22F1011. Nama pensyarah Puan Rasidah binti Siddiq. In and of chapter 2, I choose topic 4, which is field effect transistor FET. First, introduction. The field effect transistor FET is 3-terminal voltage control device used in application and switching application. The primary difference between the two types of transistor is the fact that the BJT transistor is current control device. JFET transistor is a voltage control device. In each case, the current of the output circuit is being controlled by a parameter of the input. This is two types of FETs. First, junction field effect transistor JFET. Second, metal oxide semiconductor field effect transistor MOSFET. First, JFET. JFET is a 3-terminal device with one terminal capable of controlling the current between the other two. A JFET can be either P channel or N channel. The terminals of a JFET are the source, gate and drain. JFET characteristics and parameters. Let's first take a look at the effect with a VGS of 0 volt. This is produced by shorting the gate to source junction. Next, JFET drain curve. This is a picture for JFET drain curve. Refer to JFET drain curve from point A to B. ID increase proportionally with increase of VDD. VDS increase as VDD increase. This is called the ohmic region, point A to B, because VDS and ID are related by Ohm's law. Next, MOSFET. The metal oxide semiconductor field effect transistor MOSFET is a transistor used for amplifying or switching electronic signals. The channel can be of N-type or P-type, called an MOSFET or P-MOSFET, also commonly NMOS, PMOS. In MOSFETs, a voltage on the outside insulated gate electrode can induce a conducting channel between the two other contacts called source and drain. PMOS, P-type metal oxide semiconductor logic use P-type metal oxide semiconductor field effect transistor MOSFETs is implement logic gates and other digital circuit. Physical and schematic diagram. This is a picture the MOSFET of operation. E-MOSFET. There are some similarities and construction and mode of operation between depletion type and enrichment type MOSFETs. Current control in a N-channel device is now effected by a positive gate to source voltage rather than the range of negative voltage encountered in N-channel depletion type MOSFETs. The characteristics of the enrichment type MOSFET are quite different from anything obtained thus far. This is picture of NMOS IV characteristic. Cut-off mode occurs when VGS VTH ID equal to 0. Triad linear mode occurs when VGS, VTH and VDS. Saturation mode occurs when VGS, VTH and VDS. PMOS IV curve. Cut-off mode occurs when VGS, VTH ID equal to 0. Triad linear mode occurs when VGS, VTH and VGS. Saturation mode occurs when VGS, VTH and VGS per VTH. This is JFET amplifier formula. Vs equal to IDRS per equal to VDD per 4. Vs equal to VGS, VG equal to R2 per R1 plus R2. VDD. ID equal to Vs per Rs equal to VGS tolak VGS per Rs.
So this is chapter 5 iaitu introduction to other electronic device. Electronic device have SCR, silicon controller rectifier, diode for alternating current, triode for alternating current, UJT unijunction transistor. Silicon controller rectifier and SCR consists of 4 layers of alternating P and N-type semiconductor materials. As the terminology indicates, the SCR is a rectifier constructed of silicon material with a third terminal for control purpose. Silicon was chosen because of its high temperature and power capabilities. So this is a physical structure and cinematic symbol. This is cathode, anode gate, and ini pula SCR characteristic. A is SCR symbol and B work ampere characteristic. It is a semi-controlled device. The device is turned on by applying a short push across the gate and cathode. Once the device turns on, the gate loses its control to turn off the device. The turn off is achieved by applying a reverse voltage across the anode and cathode. Holding current IH is the value of current which the SCR switch from the conduction state to the forward blocking region under state conduction. That is SCR mode of operation. In the normal of state, the device restricts current to the leakage current. When the gate to cathode voltage exceeds a certain threshold, the device turns on and conducts current. The device will remain in the on state even after gate current is removed so long as current through the device remains above the holding current. Next is condi. Once current falls below the holding current for an appropriate period of time, the device will switch off. If the gate is pushed and the current through the device is below the holding current, the device will remain in the off state. Next, SCR application. SCR application mainly used in device where the control of high power, possibly coupled with high voltage, is demanded. Suitable for use in medium to high voltage AC power control applications such as lamp dimming regulators and motor control. SCRs and similar devices are used for rectification of high power AC in high voltage direct current power transmission. Thank you. Tamat sudah. Slide kami seperti mana tamatlah sudah. Hubungan yang dulunya rapat kini sudah renggang kerana orang ketiga. Jika ada pertanyaan kami akan sediakan jawapan bukannya harapan.